Heidi-ho, everyone. We're going to look at 2.3 today, which is all about the real zeros of polynomial functions. This is a super short unit, so hopefully this goes pretty quick for us. But I'm just going to say ahead of time, if you have any questions about synthetic division, which we're going to go over today, then just reach out and I'm sure it's a quick fix. But that's basically what we're focusing on today, is learning how to use synthetic division and what does it mean for us, okay? So we actually only have two objectives today. We're not going to do this third one, so we can cross that off, right? But our first objective is to use synthetic division to divide polynomials by binomials in the form of x minus k. And then we're going to use the remainder theorem and factor theorem to figure out problems, I guess. I don't know. I just totally blanked, okay? Just to figure out, we can evaluate, I guess we should say, we can evaluate large polynomials by using the remainder theorem, and we can figure out if something is a factor by using the factor theorem. Okay, so I just want to point this out real quick. The book does discuss how to divide polynomials using long division. If you are dying to know how to divide by long division, please go ahead and look at that. However, there is a shortcut. The shortcut is synthetic division, and we are just going to focus on the shortcut. So we're just going to do the easy one. Okay, don't worry about the longer, more ugly long division unless you are just absolutely dying to know how to do it. Okay, so real quickly, we're going to talk through the steps of using synthetic division, but I have a feeling that it's not going to make any sense until we actually do a problem. Okay. But here, to divide a polynomial by x minus c, so like in this case, right, x plus 3, x plus 1, x minus 7, whatever it is, okay, to divide it by x minus c, you're going to write c for the divisor x minus c. It's always the opposite sign. Okay, so I want to make a note here, or it would be negative c if your divisor is x plus c. Okay, so you always take the opposite sign. So if it's x plus 4, I would have negative 4. And if it's x minus 7, I would have positive 7. And then it says to the right, write the coefficients, so the numbers in front of the variable in descending powers, with 0 for any missing terms. And that's really important. And that's something that's easily forgotten, okay? Bring down the leading coefficient, multiply by c, blah, 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 blah. I'm not even going to go over the rest of these steps because they don't make any sense unless you're actually doing it anyway. Okay, this is just the part that I wanted to make really clear, okay? So I'm going to scroll down and I'm just going to show you how to use synthetic division, okay? So what we do is we take our divisor. Right now I'm dividing by x plus 3, which means my c is negative 3. Right, I always take if I set x plus 3 equal to 0 and solve, I get x is equal to negative 3, right? So that's my divisor. So I'm really dividing by negative 3. And then I make this little box like so. And then I take my coefficients of my exponent, or of my terms, in descending order. So right now I have x to the 4th. That is the highest power. The coefficient in front of that is a 1. So I put a 1. Now I don't have any x to the 3rd. Do you see that? So it's x to the 4th plus 0 x to the 3rd because I don't have an x to the 3rd. So I need to make sure I include the 0, right? Then minus 10x squared. So it goes 4, 3, 2. So my next coefficient is negative 10. And then 1 is negative 2x. So my next one is negative 2. And then I have plus 4. So positive 4. So hopefully that makes sense why I have this 0 in here, because my exponents have to go 4, 3, 2, 1, 0. Okay? All right, so what we do, the first term comes straight down. That is a 1. Then I multiply 1 times -3, which is -3. And then I add. So 0 plus -3 is -3. And then I just repeat. -3 times -3 is +9. So I multiplied. And then I add. I get -1. And then I multiply. So -3 times -1 is +3. And then I add. -2 plus 3 is 1. -3 times 1 is -3. And I add 4 plus -3 is 1. And whatever that last number is, we put in a little box because that's my remainder. Okay, so I like to use Q here, and that's a common one because it's for quotient, right? I've divided, so since I started, my biggest exponent was x to the 4th. My answer is going to be x to the 3rd. It's always one less than your biggest exponent. So in this case, I have 1 x to the 3rd. Then my next coefficient is -3, so minus 3x squared. Then I have minus 1x. And I have plus 1. And then what's happening here with the remainder? So plus, my remainder is 1, but it's 1 over whatever I'm dividing by, which in this case was x plus 3. So you take whatever the remainder is and you put it over your divisor. And that is my answer. I have just divided by using synthetic division. Okay, so let's do another one together. I'm gonna get rid of that so I can have room. Okay, here, my C value is -1. That's what I'm dividing by. Because, right, if I set x plus 1 equal to 0 and solve, I get x equals -1. And then I need to go in order. Well, my biggest exponent is a 5. So the leading coefficient there is 3. I don't have an x to the 4th. Do you see that? So I have to put in a 0. Then my x to the 3rd is 4. Then my x squared is -7. Then my x to the 1, I don't have an x to the 1, so it's 0 again. And then my x to the 0 is +1. So I'm going to do the process. The 3 comes down. 3 times -1 is -3. And I add, I get -3. And then we multiply, so I get +3. Add, you get 7. Multiply, I get -7. Add, I get -14. Multiply, I get +14. Add, +14. Multiply, I get -14. Add, I get -13. And that last number goes in a little box because that's my remainder. So my answer here is Q of x. Since my highest exponent was a 5, my answer is going to be 1 less than that. So I'm going to start with x to the 4th. So my coefficient is 3. So 3x to the 4th. Then my next coefficient is -3. So -3x to the 3rd. Then my next coefficient is 7. So plus 7x squared. Next coefficient is -14, so -14x. And then my next coefficient is 14, so I have 14. And then I'm going to add, and my remainder is -13, so -13 on top. And I divided by x plus 1, so that's what goes on the bottom. That's my remainder. And there's my answer. Okay, so I want you guys to try these A and B here. Give it a shot. If you mess up, that's okay. It's no big deal. But give it, give it a good old college try. And when you're ready to go over it, go ahead and just hit play. Okay, so let's go over our work here. So I'm dividing by -2. Okay, so my highest exponent here is a 3. The coefficient there is a 1. And I can do better than this. So 1. Then I don't have an x squared, so that's going to be 0 because I don't have an x squared. Then my x to the 1 is -7, and then my x to the 0 is -6. So the 1 just comes straight down, and I multiply, which is -2, and I add. And then I multiply, which is 4, and I add. And I multiply, which is 6, and I add. And this is okay. This just means that there's no remainder, and that's all right. Okay, so q of x is equal to, and since my highest exponent was a 3, I'm going to start with a 2. So 1x squared minus 2x minus 3. And there's no remainder, and that's fine. There doesn't always have to be a remainder. Okay, so then for b, I have x minus 2, so I'm dividing by 2. My highest exponent is a 3, and the coefficient there is a 5. So that's x to the 3rd. X squared is -6. X to the 1 is +3. And x to the 0 is 11. 5 comes down. And I multiply. And then add. And then I multiply. And then add. And then I multiply. And I add. So in this case, my remainder is 33. So q of x equals, my highest exponent was a 3, so I'm going to start with a 2. So 5x squared plus 4x plus 11 plus 33 over what I divided by, which is x minus 2. And there's my answer. Okay, so hopefully that's making sense on synthetic division. Pretty quick and easy. Way better than using long division to do that. What we're going to look at now is why are we using synthetic division and how does it help us, okay? So the remainder theorem is super quick here. All this is saying is, let's say that I have a polynomial with like 10 different terms, right? Just a really long polynomial. And I want to know what I get when I plug in 7. Well, that's going to be a lot of work, right? Like I can do it. I can plug in 7 and solve all the terms and figure it out. Or I can use the remainder theorem. And so what you do is you divide by that number. So I would divide by 7, and it would, whatever the remainder is my answer. So we're just gonna scroll down here, and I'm just gonna show you how this works, okay? And then you're gonna be like, oh my God, that's so easy. Okay, so here, I wanna use the remainder theorem to find f of -2. Could I just plug in -2, -2, yeah, sure. But it's gonna be a lot of work, right? Or I can just use synthetic division, which is quick and easy. X to the 3rd is 3. X squared is 8. X to the 1 is 5. And x to the 0 is -7. 3 comes down. Multiply, so -6, and then add. Multiply, which is -4, and add. Multiply, which is -2, and add. Whatever that last number is that's what you get. So if I were to plug in f of -2, I would get -9. And that is way faster than plugging in the number, right? Faster than plugging in the number. If you don't believe me, go ahead and plug in -2 here and solve, but you will get -9. Okay, so do part B real quick. Find the value at -2. So find h of -2 of this function. So make sure you go right, set up your synthetic division, and you're just going to divide by -2. So go ahead and hit pause, and then when you're ready to check your work, hit play, and we'll go over it. Okay, so hopefully we set up -2 on the outside, right? My highest exponent is a 4, so that's 2. X to the third is 11. X squared is 9. X to the 1 is -1, and x to the 0 is -4. 2 comes down, and I multiply and add. And then I multiply and add. And I multiply and add. And then multiply and add. And whatever my remainder is, that's what I would get. So if I plugged in -2 into this f function, I would get out -22. Right? Pretty stinking easy, super fast, not so hard. Good. We're going to move on, okay, to the last part of our notes, which is the factor theorem. And so what this means is, if something is a factor, remember that if it's a factor, like, for example, whatever this equation looks like, if this is a factor, that means that it crosses the graph. You don't have to write this part. That means like that it crosses the graph. It would cross the graph at -1, right? So it would be doing something like this. I don't know what it looks like. Doesn't matter. But right. So when it's asking you, is x plus 1 a factor? It's asking you, does this graph cross the x-axis at -1? If I were to factor this equation out, would x plus 1 be a factor along with whatever else and whatever else and whatever else, right? So that's what it's asking us. Now, I don't know how to factor x to the fourth minus x cubed minus 2x squared plus 7x minus 4. Okay, I don't know. So what the factor theorem tells us is that if I use synthetic division, and I divide by a potential factor and I get a remainder of 0, then it is a factor. So if I get a remainder of 0, then it is a factor. Okay, so let's look here. If I divide by -1, right, because that's my actual c is -1, and then I have, not x. If I have 1, because x to the fourth is 1, x to the third is -1, x squared is -2, x to the 1 is 7, and x to the 0 is -4. So the 1 comes down, and I multiply and add. I multiply and add. And multiply and add. And multiply and add. Since I get a remainder of -11, that is not 0, right? -11 is not 0. So no, x plus 1 is not a factor. So that graph does not cross the x-axis at -1. Okay, if it did cross the x-axis at -1, the remainder would be 0. Hopefully that kind of makes sense there. We're going to do one more example together, and then we're kind of done with 2, 3. The last example says, show that x minus 2 and x plus 3 are factors, and then find the remaining factors. So we're just going to pick one to start with. Let's start with x minus 2, just because it's written first. So I'm going to divide by 2, because that's my c. And I'm going to go in order. I have x to the 4th, which is 2, x cubed, which is 7, x squared, which is negative 4, x to the 1, which is negative 27, and x to the 0, which is negative 18. Don't forget that if you're missing a term, you have to plug in 0. So the 2 comes down. 2 times 2 is 4. And I add, and I get 11. 2 times 11 is 22. I add, and I get 18. 2 times 18 is 36. And I add, and I get 9. 2 times 9 is 18. And I add, and I get 0. So since my remainder is 0, then x minus 2 is a factor. Is a factor. Okay, and then what's super cool is that I can actually just go ahead and divide again, right? But this time I'm going to divide by my next factor, which is negative 3. And I'm just going to do the same thing. The 2 comes down. I'm going to multiply and add. And then I'm going to multiply and add. And then multiply and add. And since I get a remainder of 0 again, right, that's good. That means that x plus 3 is a factor. Okay, so I've shown now that x minus 2 and x plus 3 are factors. Now I have to look at what do I have left. Well, I started with x to the 4th, but I divided twice. So when I divide the first time, I get x to the 3rd. And then if I divide again, I get x squared. So this is actually a coefficient of 2, and then it's actually x squared because I've divided twice. Okay, and then I have plus 5x plus 3. So that's what's left. And so I started with x to the 4th, but because I divided twice, my answer is x squared. And then it says, then find the remaining factors. Well, if I factor this, which, use Xbox or whatever, this factors into 2x plus 3, x plus 1. And if you want to actually do the Xbox to show that, go for it. But I'm going to go ahead and give it to you. So those are the other 4 factors. So there are 4 factors in this problem, and they are x minus 2, x plus 3, 2x plus 3, and x plus 1. Okay, so this is this problem completely factored out, meaning if I were to multiply out all of these parentheses, I would get this right here. But this tells me now I know where it crosses the x-axis. I know what the multiplicity is, so I know how it's crossing the x-axis. And we'll get into all of that later on as well, but this is going to be very helpful for us in future lessons, okay? So the last thing to look at here is just a reminder of the remainder theorem. So the remainder theorem provides the following information. It tells me the value if I plug in a number, right? What is the value at 7? Divide by 7. Okay, it can help me find the factors. So using synthetic division helps me find the factors if I need to. And then if I know the factors, then I can find the x-intercepts. Okay, so that's actually it for 2-3. It was a super short lesson. We're going to be using all of that information again in 2-5. So don't forget all the synthetic division and stuff like that. And then we're also be going to do it again in 2-6 and 2-7. So just make sure that we're feeling really good about this. If you're not, reach out and let us know. Otherwise, we'll see you when we do 2-4.